we are going to find the value of second root of this expression, but where should we assert the solution? As you know, 16 is a perfect square, so square root of 16 is 4. But how about 12? 12 is not a perfect square, so what can we do? Welcome to Math with Teacher MJ. In this video, we are going to solve this one little math problem. But before I start the solution, please feel free, pause the video, solve it yourself, then compare your answers with my solution. Remember, if you have a different way to solve this question, please let me know. It always makes me happy to see how creative you guys can be. Now I'm going to start the solution after 3 seconds. 1, 2, go ahead and get started. I'm going to start the solution by working in this inner part, which means second root of 16 minus second root of 12. Let me write it. We have second root of 16 minus second root of 12. As you know, 16 is a perfect square, so second root of 16 is 4. Let me write it here, minus. Well, what is 12? 12 can be written as a product of two numbers, 4 times 3. So I write here second root of 4 times 3. But what is the next step? To continue the solution, I'm going to get help from a math rule that says second root of a times b is second root of a times second root of b. So second root of 4 times 3 can be written as, we write it here 4, this one can be written as second root of 4 times second root of 3. Now, all you know, what is second root of 4? Second root of 4 is 2. Let me rewrite it, 4 minus 2 times second root of 3. But what is the next step? To continue the solution, I'm going to rewrite this 4 as the sum of two numbers, which means 1 and 3. This 4 can be written as the sum of 3 and 1. Let me write it here. 3 plus 1 minus 2 second root of 3. But what is the next step? Let me write it here. Here we have 3, 1, negative 2 times second root of 3. I'm going to replace these two terms, so it's gonna be 3 minus 2 times second root of 3 plus 1. But what is this? If you think carefully, you can find the continue of the solution easily. But let me help you. I'm going to follow an algebraic identity that says a minus b to the power of 2 is same as to the power of difference of two terms is going to be first term to the power of 2 minus twice of the product of the first term and second term plus second term to the power of 2. So, how can we get help from these two continue the solution? What do we have here? This one perfect square like this. How about this one or this one? 3 is not a perfect square, but 3 can be written as second root of 3 to the power of 2, right? Let's see what do we have here. I write second root of 3 to the power of 2 instead of 3, minus 2 times second root of 3 times 1. This one is exactly this one, plus 1 to the power of 2, that is same as 1. Now we have this left side, we can continue from this right side and write this left side. So it is going to be a square root of 3 minus 1 to the power of 2. Until here, alright. But this is still this inner part. We need to find out the second root of this, which means this. We are going to find out this. But how can we do this? A very simple math rule. These two as exponent, these two as root can be cancelled off. So the answer is second root of 3 minus 1. But do not forget, what do we need here? Right, absolute value. Now let's see what is the final answer. As you know, second root of 3 is same as 1.732. So let me write it here, 1.732 minus this one. What is the final answer? Absolutely, final answer is 0.732. And this is the most simplified answer of our question. But do not forget, if you use different way to solve this question, please let me know. Have fun.